thanks. I think in a sense my talk would be an introduction to Nina's talk. Unfortunately, time is linear, but you can rely on memory. So I will also focus on computation in language. I will give a kind of very quick outline, quick tutorial on the basic ingredients that linguists believe are essential for linguistic computation. So I'll talk about structure building, how it works, movement in a extended sense, the rules that concern interfaces between syntax and systems dealing with sound and meaning. Then I will look at the critical issue of language invariance and variation and try to offer you a view of how current models look at this central problem with a kind of updated version of the principles and parameters approach. And then in the last part, if there is time, I'd like to say something about language acquisition, and particularly I'd like to comment on a little experiment that bears on a very large and important question: how we acquire language. Okay, so I think a good starting point is the observation of the unbounded scope of human linguistic capacities, right? The fact that is constantly under our eyes is that we understand and produce new sentences that we have not heard, and we find them familiar, we can use them. So how is that possible? Major thinkers in the past thought about this problem. I think the first real scientific contribution came from Chomsky's work in the 50s. Chomsky claimed that knowing a language means possessing a little computing machine, essentially, with at least two kinds of entities. There are certain inventories, there are certain lists that are memorized and that can be accessed, let's say words or morphemes, groups, and so on. And then there are computational procedures which put together elements and form higher order units, phrases, sentences, and so on. And the crucial property of these systems is that they are recursive. That is to say, rules can indefinitely reapply on their own input, and that's the basic secret, basic trick that determines the unbounded nature of our linguistic capacities. So in this system, syntax undoubtedly is the generative heart of the system. On the other hand, it's also ancillary in some sense to the needs of systems of sounds and systems of meanings, in that it determines an infinite number of potential sound-meaning pairings, and sounds and meanings are what really matter to us, right? So we want to express meanings and want to communicate them to others. Now, is there any real alternative to this computational approach? Could it be, for instance, that we just memorize fragments? We hear sentences, we memorize them, we hear words, memorize little bits, and we reuse them? Not really. This would clearly beg the question of creativity that I've just tried to state. Now, could it be that we create new sentences through some kind of analogical generalization from memorized fragments? So we hear fragments, memorize them, and then we analogically generalize from these things. The problem is that, unfortunately, this statement is neither true nor false, right? Because the problem precisely is, why is it that every child unerringly makes certain analogical generalizations and discards a priori other conceivable analogical generalizations, right? So it's only if we try to give some context to the notion of logical generalization that this hypothesis will make predictions. But then we may as well use another name. Use another, like Luigi, for instance. Structured analogical generalization. Okay, now some recent developments, both on the inventories and on the computational devices. About the inventories, there has been a shift from the contentive lexicon, the lexicon that has descriptive content to the functional lexicon, which turned out to be much richer and more structured than we thought. Functional lexicon are familiar things like determiners, auxiliaries, comparative, but also specifications of tense, mood, aspect, voice, and so on and so forth. Now, in what sense functional elements are so important, so central? Well, first of all, they create certain configurational skeleton for the insertion of contentive elements. And functional structures are quite complicated, so much so that a research trend has acquired a sort of autonomy which basically tries to describe that complexity. That's the so-called cartographic project, essentially drawing maps as precise as possible of the complexity of functional structures. Then the second thing is that functional elements trigger the fundamental computational processes, in the sense that we made clear, and then they also express basic parameters of variation. So variation is largely localized in the functional lexicon. Now, as far as computations, there also has been progress, or at least change and shifts of emphasis from concrete and construction-oriented rule systems. Like when I was a student, we worked with transformations that had to do with, say, relatives, questions, passing, and so on and so forth. So from such concrete construction-oriented entities to much more abstract computational ingredients. Things like merge, basically take two things, put them together and form a unit. Search, establish a relation between 2 points in the tree. Label, give a name to the entity that you have created. Move, that I will go back to, spell out instructions about how to pronounce certain entities, certain structures that have been generated by the system. These are clearly much more abstract. Now there's a debate, do constructions exist or not? My personal view is that constructions exist, but they are molecular. They are not atomic entities. So construction is really a conglomerate, a structured conglomerate of these more elementary entities. And we need this type of granularity to seriously use syntax. Now, after about half a century of discussion, linguists, that is some linguists, came to the conclusion that the fundamental recursive procedure is more or less the sequence you can think of. Procedure merge, take two things, glue them together, form a third thing, and then you need some kind of labeling algorithm that will give a name to the entity that you have created. And this procedure is recursive because you can immediately reapply to its own output. Now, just a little example, we put together 2 words, for instance, and then we can continue and glue a word to what we have just created, and then we go on by merging words to structures that we have created, and this will produce complex structures of this kind, which we may represent in a pictorially more efficient way through a tree of this sort, which in a sense recapitulates what has happened in the generation, the successive applications of merge. Now, development, if you take the magnifier and you look at a single node of this kind of representation, for instance, this node, you observe that there's much more complexity there, which is somehow fractally related to the nodes that you see with the naked eye, so to speak, right? So, in a sense, I think, so this is the complementizer system in my analysis of the complementizer in Italian. In a sense, syntactic structures in this view are like crystals. So if you look at them with the naked eye and with a microscope, you see the same structure, essentially. Same basic ingredients. Heads that are merged with dependents following certain general rules. Okay, this is merge. Then there's movement. Now, there are claims that certain theories do not have movement. That's not true, really. If you look at movement in a sufficiently abstract way, movement is just a relation between 2 positions. So, which book should I read? Any theory that deals with questions must express the fact that a certain element is pronounced in a way, in a position which is different from a position in which it receives some kind of argumental semantic role. It should be interpreted as the element of the verb read. So the classical story about movement is that the element is merged in the position in which it receives a certain thematic role, and then it's displaced to another position. But different types of theories may be more or less faithful to the metaphor of movement. For instance, GB theory is very faithful, but minimalism is not faithful at all. There's no actual displacement from one position to another. In minimalism, what happens is that you proceed through steps in the following way. You first start with a basic nuclear sentence, and then you try to form a question, and this guy starts a search to identify a possible candidate for being remerged, and then you just remerge the candidate that you have identified to the whole structure, and you get the equivalent of displacement without actual displacement, without physical displacement. You get a structure of this kind with this position, which is a copy of the position that has been remerged with everything except that it's not pronounced, but it's there in the mental representation of the structure. Okay, so this way of looking at movement as internal merge immediately explains Emmons' observation about structure preservation. Emmons, many years ago, had observed that movement is structure preserved, since it creates structures that could be independently generated by the structure building mechanism. Now, this property is explained in this way of looking at things because movement actually is a subcase of the structure building mechanism. So, not surprisingly, it is structure preserved. Now, merge movement meaning, sometimes when I give this kind of talk, people get the feeling that movement, merge, and so on are kind of purely formal rules. Rules of purely formal game that has nothing to do with meaning. That's completely false. Well, let me try to give a different impression. In fact, clearly both merge and move are immediately utilized for the expression of meaning. There is a certain division of labor between merge and move. Here I continue to talk about move, even though I accept the idea that it is a special case of merge, but it's possible to legitimately distinguish between the two operations. So merge creates configurations for the expression of argumental semantics. Essentially, who does what to whom in the event that we describe, right? Assignment of thematic roles, if you want to use that term. Move creates configurations for the expression of scope discourse semantics, essentially the scope of operators and certain discourse-related properties such as topic, focus, new information, old information, and so on and so forth. And there is a division of labor between the two things. So merge basically contributes, creates structures in which argumental properties are assigned, such as thematic roles. This is oversimplified. In fact, the kind of theory of the lower part of the causal structure that Rizzi referred to in this morning's discussion suggests that even for a simple transitive verb of this sort, there's more structure than what is shown here, but it's enough for our purposes. So basically, merge creates the configuration in which thematic roles are assigned. Now, move creates operations for scope discourse semantics. For instance, what we just saw, the move operation that creates a WH construction in English, for instance, determines a configuration that is close to the kind of logical form that we want to obtain with an operator that binds a variable in the structure. The same is true for other discourse-related properties, such as topic comment configurations. Take, for instance, a structure with topicalization, like your book I will read tomorrow, something like that. It's obtained essentially through move, by moving a certain element that receives a certain kind of argumental role in one position to a dedicated position in the left periphery where it gets the interpretation of topic of the structure. And we can think that topic comment is interpreted by the interface system partly along the same lines as the assignment of thematic roles. That is to say, this way of looking at things, which is my own, so that I don't claim that everybody literally agrees with that, but in this way, the system is populated of functional heads, like topic head, which comes with very specific instructions to the interface systems, like interpret my specifier as the topic and my complement as the comment. That gives the topic comment configuration. Similar story for the focus presupposition configuration. Take a construction like a cleft construction in English. It's your book, I will read tomorrow, something like that. But you want to interpret this element as focal and the rest as presupposed. You may think that the syntactic configuration is similar. So there is a dedicated head in the left periphery that attracts an element and that determines a certain type of interpretation, focal interpretation, and then the instruction about the interpretation of the complement of that head is interpreted as the presupposition. Now, these elements speak to the interface with meaning, but also to the interface with sound, so that here you get the two pitch contours going with topic comment and focus presupposition in Italian. In English should be a little bit different, but you can think that basically the rules that interface with sound read the syntactic structures that we have just seen and assign the different pitch contours that we, very different, clearly different pitch contours that we have with this kind of discourse, scope discourse, semantic interpretive properties. Okay? Now, as I said, this is my personal view, not everybody agrees with that, but it seems to me that one kind of evidence which strongly favors this highly structural view of how to do scope discourse semantics is that in many languages we actually pronounce the little heads that are abstractly postulated in languages like English and Italian. So here we have, for instance, a question marker in certain Dutch varieties. Here we have many languages have topic and focus markers. For instance, the African language Gumbe, studied by is here. So it seems to me that one can assume that there is a trivial parameterization distinguishing these cases from languages like English, Italian, and so on, just to do with whether or not the relevant system of heads is pronounced. Okay, so in short, this system of left peripheral heads does three things. In syntax, it triggers movement, external memory. Right? So it makes an element move to or be remerged in the left periphery. Now, the semantic interface triggers interpretive routines like topic comment, focus presupposition, and the phonetics interface triggers intonational contour assignment. Okay, so a syntactic function and two interface functions. But you can see how merge and move are very directly finalized to deal with, to the expression of certain elements of meaning in this system. Okay, now let's turn to language invariance and variation. We compare languages, thanks. I interpret it in an extended way. Certain properties vary, other properties are constant, right? And particular grammars and universal grammars are the entities that deal with these aspects. An important improvement was determined by the introduction of principles and parameters models in the mid-70s, early 80s, in which universal grammar is a system of general principles that gives the general structure of language, and variation is determined by a finite number of binary choice points parameters. And as you know, the introduction of this system had pervasive consequences both in the study of comparative syntax and of language acquisition. Chomsky somehow acknowledges the important inspiring function that work in fundamental biology, like people like Jacques Monod, François Jacob, and others had in thinking of the system, in which a very tiny modification in one spot determines systemic consequences in the phenotype, in the language. Now, in current models, I think that we should think of parameters as instruction for a particular syntactic action. A parameter is an instruction that says, do this, essentially. And they are expressed by features that are assigned to elements of the functional lexicon and made operative when the element enters syntax. So a parameter is an instruction for a syntactic action. So we can think that the format of parameter is as simple as that. Age, which is an element of the functional lexicon, has a certain property, yes or no. Or the property is an instruction to perform merge or move, or one of the small list of actions that I listed. The locus of parameter, the place where they are expressed, is the functional lexicon. Okay, so these are the two notions that we need. So in this system, UG specifies the following things: the functional lexicon, the list of syntactic actions, we have seen merge, move, search, and so on, spell out, the list of features triggering syntactic actions, and then the format for parameters, this kind of thing. And so we have merge parameters, so the instruction to perform merge, move parameters, spell out parameters, and the task of the child, seen from this viewpoint, is to associate, essentially, the appropriate set of values to each age, to each element of the functional lexicon he postulates. Okay, so we have seen the typology of parameters. Now, there are many parameters, of course, in this system, because they are somehow determined by the numerosity of the functional lexicon. The functional lexicon is big. We have many, many functional elements, particularly so if cartographic studies are on the right track. And certainly we're talking about hundreds of elements. Now, is this a problem? It's a problem to have so many parameters. For some people, it is a problem. Like Fritz Neumayer, for instance, claimed that such assumptions on the numerosity of parameters are a kind of reductio ad absurdum of the very idea of parametric syntax. The idea that syntactic diversity is amenable to a finite set of binary options, because there are so many options that it's like an undeclared retreat to pre-parametric models, to accept standard theory models, which looked at individual grammars as language-specific rule systems. I don't think this is correct. I think there's a confusion here between the locus and the format of parameters. Under this conception, the loci of parameters are very numerous, because the functional lexicon is very big. But the format is extraordinarily restricted, because there are very few actions that we can do. This handful of actions that I mentioned before. So that these models are much more restrict the space of possible languages in a way that is much more effective than EST, extended standard theory types of models, for the reasons I mentioned. Okay, here I have an example of a parameter, ordering parameter, but I think I will skip this in the interest of time. And I will very briefly conclude with mentioning a little experiment that bears on a big question, which is how do we acquire language? How do we acquire some of the properties that I mentioned? Take the fact that every child must acquire this languages OV or VO. Eat cake, like English, or cake eat, like Japanese, right? Very simple problem. The UG hypothesis is that, well, the child has abstract grammatical representations early on, expressed by principles and parameters, and parameter fixation is right. The opposite hypothesis, constructivist or neo-constructivist, or however you want to call it, hypothesis, says that no, things work differently. Initially, the child simply stores in memory individual items and with memorized syntactic frames. So there's only concrete knowledge. And it's only later, much later, in work like Maselli, for instance, that the child generalizes through analogy from memorized fragments to abstract notions like my language is VO or OV, or this is a verb, and so on and so forth. With that. Now, if you corpus studies, so you look at corporal productions, you see that already in the two-word stage, children already produce structures that correspond to the basic order of the language. So the child learning English will say eat cake, and the child learning Japanese will typically say cake eat. Okay? But this is immediately interpretable by both approaches. Now, for the UG approach, this early production manifests early parameter fixation. For the constructivist approach, well, the child simply reproduces what he hears. He hears here's an int k, and he says int k. Here's k int, and it produces int k int. I cannot speak your final language, so that's some trouble. Now, of course, the two approaches make different predictions on the child's capacity to generalize her knowledge to new items and structures in that stage, right? Clearly, there should be generalization according to this approach. There should be no generalization according to this approach because the child is very concrete at this point, and only much later on. So here's the little experiment. 3 ingredients, preferential looking paradigm, 2 videos, and then measure how much time the child looks at one or the other. Pseudo verbs, Jabberwocky, so that these are verbs that the child has never heard by definition. Then weird word order languages, and also with certain things that Lina showed us. Grammatical, well, we did this with French, so grammatical order, noun, verb, noun, and ungrammatical order, noun, noun, verb, ungrammatical in French, that would be okay. Japanese course. So the child hears things like these 2 videos. Le lion poune le cheval. This is not it's a possible but non-existent verb in French. In l'âne, le chien dase. Again, Jabberwocky verb in French. 19 months. The child sees 2 videos. Sorry, this is not clear at all, but 2 videos. One with a transitive action, when an animal does something to the other animal, like putting a crown on the other animal's head. And the intransitive or reflexive video in which each animal does something to self or whatever you want to say. Right? Like putting a crown on his own head. This both in the grammatical condition, le lion poune le cheval, and the ungrammatical condition, l'âne, le chien dase. Okay? Participants, predictions. UG approach predicts that the child has abstract knowledge that his language is SVO at 19 months, so she will immediately interpret NVN with a novel verb that she has never heard as a transitive action, and it's expected that she will look more at a transitive video. The NNV sentence doesn't correspond to any sentence in any abstract schema in the language, hence no preference would be expected here. The constructivist approach, on the other hand, would predict that the child would have, as the child doesn't have any abstract knowledge of word order, the child should not have any preference in either case. Now, here are the results. This is the grammatical NVN order. So the child looks at the transitive video about twice as much as the video with the intransitive action. Whereas in the ungrammatical condition, NNV, the child looks at the 2 videos more or less the same amount of time. Conclusion, infants well, the conclusion we drew at least, is that infants at 19 months exposed to French sharply differentiate NVN and NNV structures with verbs that they've never heard before, but they appear to have abstract knowledge that the language are exposed to is SVO. This is not really expected under at least certain varieties of constructivist approaches, which would assume only concrete and item-based knowledge at this stage, whereas the evidence seems to support or be consistent with a UG type approach, which assumes early abstract knowledge in the form of a UG parameter already fixed very early on. So this is just a drop in a C. Yes, and that's a good point to stop. But it seems to me that this kind of research will help us shed light on very important questions of how language